Hey folks, how's it going? It's Mr. Murray coming to you with a do now for Course 1 CP for Wednesday, June 10th, 2020. So in this do now, what we're going to be doing is we're going to be building off what we talked about yesterday. And so yesterday we continued to turn up the heat by taking our exponential function and adding something on. So instead of just 1/2 to the x or 2 to the x or 3 to the x, it was maybe 4 to the x minus 8, for example, like you see here. So I've added something on to the end. Okay, and what that did, it had the effect of, transforming the function somehow. So for this do now, what I want you to do is I want you to just graph the function 4 to the x minus 8, thinking about what should you always make when you make a graph. So please pause the video, do that thing, make the graph, and then when you're ready, unpause, and you can see what I got. Okay, so let's take a look. So that thing that you always need to make, yeah, folks, that would happen to be a table. Now, I know you might think it's cheesy or corny or, whatever you guys say nowadays, but it's really important that you always make a table. Because what you're doing is you're making a picture of a function. Okay? And a picture of a function is just essentially every single point that's on the function. So the ones you can find and everything in between. And so those points, those anchor points, I guess you could call them, well, those are going to come from your table. So I know it's something that is not like exciting, but you have to be willing to put in the time at least to find enough information to know where it goes. One thing that I'm seeing so far is that I think that the part where it's going up really fast is generally pretty good, but the asymptote is where we're still struggling, so we're going to have to continue to work on that. Okay? All right, so let's plug in some numbers. Let's start with our table. So remember, anything to the power of 0 is always equal to 1. Another thing I've seen, and it's totally understandable, some people think 0, like you're multiplying by 0, but when 0 is an exponent, you should be getting 1. So 4 to the 0 is 1, and then 1 minus 8 is negative 7. And then 0, negative 7 becomes a point on the graph. Now I plug in 1, 4 to the 1. Well, anything to the power of 1 is itself. So 4 to the power of 1 is 4. 4 minus 8, 1, 2, 3, 4. Right? All right, 2. 4 squared is 16, minus 8 is 8. So 2, 1, 2, 3, 4, 5, 6, 7, 8. All right, 4 cubed. 4 times 4 is 16. 16 times 4 is 64. 64 minus 8 is 56. So it's way off the graph, and so we're done, and that's okay. Negative 1. So remember, anything to the negative x to the negative a, remember, first you do the reciprocal, and then you make the power positive. Okay? So 4 to the negative 1 is 1 over 4 to the positive 1, or 1 over 4. Minus 8, and that is 7 3/4. If you do negative 2, what you're going to get is 1 over 4 squared. And 4 squared is 16, so it's 1 over 16 minus 8. So that's negative 7 and 15. So you see what we're getting really close to here is 8. Negative 8, rather. And now that you know you're getting really close to negative 8, you can kind of wing it a little bit on the tail. That's okay. Look, I'm not expecting perfection, but what I'm saying is I am looking for you guys to give me just a little bit more with regard to the asymptote, because that is an extremely important feature that makes this function unique. Okay? The only function we've ever seen that has an asymptote is an exponential function. So if it's so unique, it's something I'm going to want to make sure you guys can graph. All right, so hopefully you're able to get this right. If so, congratulations. Otherwise, I'd be thinking about some questions you can ask during tomorrow's hangout, where we're going to be talking about the laws of exponents as well as exponential functions. All right, best of luck, folks. Don't forget to love math, and remember, you can do it.